Today we're going to talk about transformer selection and what information you need in order to pick 3 single-phase transformers for banking or paralleling transformers together. So first you need a work order or construction print that shows you the circuit voltage on the system, and then it also shows you the service voltage needed, and then what size transformers needed. So up in the left-hand corner, we're going to kind of write a work order out here, and we're going to say that the circuit voltage is 7200, 12470. And then we're going to say that our service voltage is 12240 that the customer needs. And they're requiring 3 25 kVA transformers. So this would be on our work order, and these are parts of the equation that we need. So compare this with our transformer nameplate. And on the high voltage rating of the transformer, we've got a match because we've got 7,200 volts, which matches the phase to ground connection on our circuit voltage. Then, if we look at the service voltage, we've got 12240 on our transformer nameplate, which matches the service voltage required by the customer on the work order. And then the last part there is the size of the transformers. And right over here, what I'm circling right now, we've got 25 kVA is the size of our transformers, which matches on the work order, the 3 25 kVA transformers. So there's the first 3 things we need. The circuit voltage matches on the transformer voltage rating. Then the service voltage is a match, and the size of the transformers is a match. So when we're banking transformers together, there's 2 other things that we need to look at. And the first one I'm going to circle and we're going to talk about is the impedance. So when you think of impedance, think of resistance. And you want to try and get 3 transformers that have the impedance as close to each other as possible. So we've got 1.9% as our impedance. So if we move over here and we look at our transformers on the bank here, let's say that we got 1.9% on this first one. And the second one we've got 1.9%. But let's say on this last one, we've only got 1%. The reason why this is important to try and get 3 transformers that the impedance is very close together is this one transformer over here that's at 1% is going to take on more of the load. Because remember when I said when you think of impedance, think of resistance. Well, if it's got less resistance, then it's going to pack more of the load. It's going to take on more of that load, which could overload that transformer and make it fail. So you want to try and find 3 transformers that have impedance that are very close together. Some companies will give it a plus or minus 5% range, but check with your company just to find out what they require. Okay, so the last part of the equation is the polarity, and I'm going to circle it. It's right here in the middle. And you want to try and find 3 transformers that have the same polarity. In this particular case, our transformers they show additive polarity. A good way to indicate that it's additive polarity, besides the transformer nameplate, is if we look at our transformers that are banked, if the X1 bushing is on the right-hand side, then they're additive polarity. If the X1 bushings are on the left-hand side, then they're subtractive polarity, like this one on the far right. So the reason why this is important is if you've got, let's say, 2 transformers that are additive and 1 transformer that's subtractive polarity, electrically you can connect it and make it work. But it's going to be a different type of connection than the traditional connection. And this can be a hazard, especially in the middle of the night. If you come up on a connection, you're like, what is this? I've never seen this before. It could actually be a safety concern. So although electrically it will work, you want to try and find 3 transformers that have the same polarity, just to make it so the connections are traditional and look the same. Okay, so that's the criteria for choosing the right transformers, single-phase transformers, when banking or paralleling transformers. You need to know the circuit voltage, the service voltage, the size transformers you need, and then try and get the polarity to match, and try and get the impedance as close as possible for all three.